Hi guys, before we started filling out the notes on solving linear inequality word problems, I wanted to include a list in here of terms that mean less than or equal to, greater than, or greater than or equal to. And these are key words or phrases that we want to pick out of the word problems to know, do we want to use a less than sign? Do we want to use a less than or equal to sign, a greater than sign, or greater than or equal to sign? So somewhere in your notes you might want to just jot these down, take a screenshot, put it on your phone. But these are the key words or phrases that we're going to be looking for when we are writing linear inequality word problems. So if you want to pause it now and copy these down, you can go ahead and we're going to move on. Okay, so solving linear inequality word problems, it's just like a regular word problem. As always, you want to read the problem. If you don't read the problem, you don't know what you're looking for. Step 2, highlight important information. Those key words and phrases I just showed you on the previous slide will help you determine which inequality you're looking for. You, of course, always want to identify the variable. If it's an equation, you want to write the equation. Remember, an equation is going to have an equal to sign. And if it's an inequality, you want to write the inequality, which is set up just like an equation, except for you're going to use one of those inequality symbols. Less than or greater than, less than or equal to, or greater than or equal to. Step 5, you want to solve for the variable and always answer the question with units. If you just put 15, it could mean 15 chickens. And if you're talking about the number of boxes of greeting cards someone sold and you don't put boxes, we don't know what you're talking about. And then check or justify your answer. Okay, so let's take a look at example number 1. Yellow taxi cab charges $1.75 flat rate in addition to 65 cents per mile. So here's some keywords. This is a flat rate and 65 cents per mile. Katie has no more than, so if you want to go back and look at that list, no more than means less than or equal to. She has no more than $10 to spend on a ride. How many times can Katie travel without exceeding her limit? So we want to identify our variable. We could pick any variable. I'm going to let x equal the number of miles Katie can drive. Write the inequality. So if we were going to set this up as an equation, we would have our flat fee, which is $1.75, plus the 65 cents per mile, but she doesn't want to spend more than $10. So it has to be less than or equal to 10. Then we're going to solve the inequality just like we solve an equation. Here's the river. You can either clear the fraction or work with the fraction, or clear the decimal or work with the decimal. I'm going to leave the decimal as is. I'm going to subtract $1.75 from each side. Remember, that's a 10.00. I get 0.65 or 65 hundredths x is less than or equal to $8.25. Divide by 65 cents. And you get x is less than or equal to $12.69. So we solve the inequality, and that's 1,269 what? It's 1,269 miles. So I did this part right over here, so you don't need to redo it again. So check or justify your answer. Well, let's write our answer in a complete sentence. Katie can drive no more than 12.69 miles. So how are we going to check that? Let's put it back in the equation. If I do 65 hundredths times 12.69 plus the flat fee, of $1.75, is that going to be less than or equal to $10? And it will, so we did this correctly. Just go ahead and check it on your calculator. Okay, I'm going to go ahead and do example 2. If you want to pause here and then work the example out on your own and then come back and play the video to check your answer, that would probably be a good idea. So if you want to pause it, now is the time to pause it. Example 2, the low temperature for the previous 2 days, the low temperatures were 62 degrees and 58 degrees. What would the temperature need to be? So the temperature need to be on the 3rd day such that the average daily temperature is at least 64 degrees. So at least, go back again and look on that list I had on the last slide. At least means it can be 64 degrees, but it can be more than 64 degrees. So it could be 65, 66, 67. I'm going to go ahead and identify the variable. Let x equal the temperature on the 3rd day. And now we need to write the inequality. So think back to how you find an average. We're looking for the average of 3 days. So I'm just going to write this out in words. If I add up the temp on day 1 plus the temp on day 2 plus the temp on day 3, I'm looking for an average of 3 days. So I'm going to divide by 3. That average can be at least, so greater than or equal to, 64 degrees. So now I'm just going to take these numbers and plug in what I know. I know that day 1 is 62 degrees, day 2 is 58, and day 3 is what we're looking for. So 62 plus 58 plus day 3, which is x, divided by 3 is greater than or equal to 64. So there's our inequality. We need to clear that fraction, so I'm going to multiply everything by 3. These will cancel, and I'll get left with 62 plus 58 plus x is greater than or equal to 3 times 64 is 192. Combine like terms. 62 and 58 is 120. So 120 plus x is greater than or equal to 192. Subtract 120 from each side. This cancels and we get x is greater than or equal to 72, and it's 72 degrees. So what does the temperature have to be on the 3rd day such that the average daily temperature is at least 64 degrees? The temperature has to be 72 degrees or greater. So we solve the inequality. I'll just write the answer here. The temperature on the 3rd day can be at least 72 degrees. So again, it could be more than 72 degrees. So how do we check our answer? Plug it in. 62 plus 58 plus, here's where we got our answer, 72 divided by 3 has to be greater than or equal to 192. 62 plus 58 plus 72, sorry, not 192, 64. Let me erase that. So this number here should be 64. Okay, so we get 62 plus 50 is 120, so we get 192 divided by 3. Is that greater than or equal to 64? 192 divided by 3 is 64. Is 64 greater than or equal to 64? It is. So the answer is correct. So now it's your turn to answer multiple choice question number 1. Which inequality matches the scenario above? And then from question 1, what is the maximum number of DVDs Chris can purchase? And remember to put your answer in on the Google form. And when you answer number 2, make sure your answer says Chris can purchase however many CDs he can purchase.